All right, we're on Chapter 8, Section 1, which in our learning plans is 4-7. We're going to find roots of numbers, principal roots of numbers, graph functions, and then find the nth roots and powers, and use our calculator. The opposite of squaring, or inverse of squaring, is the square root. So the square root of 36 is 6, because 6 squared is 36. We can do the same thing for cube roots. That's the index is 3, or fourth roots, the index is 4. So nth root of a is b, means b to the nth is a. So the number on the outside is called the index, the radical sign, of course, and the number on the inside is called the radicand. So for each of these radicals, simplify. The first one is 3, because 3 cubed is 27. The second one is 6, because 6 cubed is 216. The third one is 16. No, it isn't. Yeah, it's 4, because the 4 to the fourth is 256. The fifth root of 243 is 3, because 3 to the fifth is 243. The fourth root of 16 over 81 is 2 over 3, because 2 to the fourth over 3 to the fourth is 16 over 81. The cube root of 0.064 is 64 over 1,000 cube root, which would be 4 over 10. Okay, so for this one, simplify these. The first one, A, is 10, B is 5, C is 1 over 4, and then D, that's the cube root of 27 over 1,000, which would be 3/10. Find this one. Fourth root of 625 is 5. Okay, so the principal square roots, if it's even and the number is positive, then it's going to be a positive number. If the number is negative and if it's even, then we would say there is no solution. If it's odd, it doesn't matter. There's always a root. So this would be 6. This would be 2. This doesn't exist because it's a square root of an even index. This would be -3. The negative sign translates out. This is -6. Now the reason it is it's like x minus the root of 36. This negative sign is the same as a subtract sign, so that's why the negative sign there makes sense. This would be -2, and this would be +3. So if you do these, first one would be -5. Second one would not exist because it's an even index with the negative sign on the inside. -2 is C, and then D is -4, which, by the way, is the same as the cube root of -64. It doesn't matter for that negative where it is. This one, 4 to the 6th, well, let's see. 4 to the 3rd is 64. 64 times 64 is 4096. Okay, so it would be -1 over 4. That's a hard one. Now, sometimes we can graph functions. For a square root function, notice it starts at 0 and goes up, and it just goes from 0 to positive infinity. For a cube root functions, it goes from -infinity to positive infinity through 0. So we're going to make a table of values here. I wonder if there is a table of values. Yep. Okay, so -2, the square root of -2 plus 2 is 0. -1 plus 2 is +1. Square root of +1 is 1. 0 plus 2, square root of 2 is 1.4. 2 plus 2 is 4, square root of 4 is 2. So At negative 2, we're at 0. At negative 1, we're at 1. At 0, we're at 1.4. And at 2, we're at 2. So you see what's happening here. It's going to go like that. Cube root of x minus 1, 0 minus 1 is negative 1. Cube root of that is negative 1. 1 minus 1 is 0. Square cube root of 0 is 0. 2 minus 1 is 1. Cube root of 1 is 1. Negative 3 minus 1 is negative 4. Cube root of negative 4. That doesn't come out evenly. That one you're probably going to want to use your calculator for. Clear. So we're going to say 3 second function cube root key negative 4 equals, I get negative 1.58. Oops, negative 1.58. 4 minus 1 is 3, cube root of 3. So it's 3 second function to the key. 3 is 1.44 positive. So at 0, it's negative 1. At 1, it's 0. At 2, it's 1. At negative 3, it's negative 1.58. And at 4, it's 1.44. So you see how it's going to go like that. Okay, do we have to do 2 of these? Yep. Okay, so for the first one, negative 2 plus 1 is negative 1, doesn't exist. Negative 1 plus 1 is 0. 0 plus 1 is 1. 2 plus 1 is 3. Square root of 3 is 1.78, I think. Second function square root 3 is 1.73. Okay, so at negative 2, hold it. No, this is the null set. This doesn't exist. Okay, at negative 1, it's 0. At 0, it's 1. At 2, it's 1.73. So our square root goes like that. For the cube root, I think this is supposed to go farther over. Maybe not. I guess it's not supposed to go farther over. So the cube root of negative 2, second function, clear, 3 second function cube root, negative 2 is negative 1.52 minus 1 is negative 2.26. Then third root of negative 1 is negative 1, minus 1 more is negative 2. Cube root of 0 minus 1 is 1. Cube root of 2, clear, 3. Third root of 2 is 1.25, minus 1 is 0.25. So negative 2, negative 2.26. Negative 1 is negative 2. 0 is negative 1. Ooh, that does not look right. 2 is 0.25. So it's going to go like this. Over 0, down 1. I didn't do that right, did I? Did I switch? No. Negative 2. Why am I off here on my dots? I'm going to change colors. That doesn't look right at all. Let's try it again. I must have been negative 2, negative 2.26. Negative 1 is negative 2. 0 is negative 1. 2 is 0.25. There we go. Okay. Ooh, we don't have a function. Here we go. X minus 3. So negative 2 minus 3 doesn't exist. Negative 1 minus 3 doesn't exist. 0 minus 3 doesn't exist. 2 minus 3 doesn't exist. We better start with 3. 3 minus 3 is 0. So over 3, up 0. 4 minus 1, there we go. So it's going to go like that. Okay, so the real number, the square root of a squared is always going to be positive a. So the square root of 15 squared is 15. The square root of y squared is y. The square root of negative 12 squared is negative 12. The square root of negative y squared is negative y. No, it's not. They're both positive. Those last two would be positive. Positive 12, positive y. That's why we always get a positive number anytime we do these square roots. Okay. So you do these. First one is 11. B is 11. C is Z. And D is Z. So whether it's positive or negative, doesn't matter. You're always going to get a positive number. Next. The nth root of anything to the nth is always going to be that number if the root is negative, if the root is odd, or the positive if it's even. So in this case, it'll be positive 5 because it's even. It'll be negative 5 because this is odd. It'll be negative 3, not because of this negative, because of this. Remember, that's like x minus that. It's going to be the negative of that. This one will be m squared because, notice this is, that's a weird way to do it. They're kind of playing games with you. It's m to the 8th, and then there will be a negative sign out front. This will be x to the 8th because it's a cube root of x to the 24th. This will be y to the 3rd because it's the 6th root of y to the 18th. Okay, you do these. A is 2. B is negative 9 because it's an odd power. C is negative 10 because this is a subtract sign. D is negative m to the 4th. E is x to the 6th. And F is, t to the 5th. Now, how do you use a calculator to find roots? Well, we take our calculator and we'd press square root key, clear, square root keys, 17. Oh, I see, my wife's calculator is not a very good one. 17 is 4.123. The next one, we could put the negative sign, but I'll just remember it at the end. So it'll be square root of 362 is negative 19.03. Cube root of 9482 is 21.17. And fourth root of 6825 is 9.089. All right. You do these. So the square root of 92, make sure you put a negative sign on the front, is negative 9.59. Fourth root of 39 is 2.50. And then the fifth root of 33 is 2.01. You do this one. I get 27.749. This one, fifth root of negative 70 is negative 2.339. Okay, a word application. In electronics, the resonant frequency of a circuit can be found by the formula. The frequency is 1 over 2 pi times the square root of LC, where L is the is in henries and C is in farads. Henries and farads are units of measure in electronics. Find the resonant frequency. So all we need to do is to just write this 1 over 2 pi square root 6 times 10 to the negative 5th times 4 times 10 to the negative 9th. So we'll use the exponential key on our calculator. 1 divided by parentheses 2 pi, and then it'll be the square root key, so that's second function square root. And the parentheses already open, so it's 6. I'm going to press the EE key, which is exponential on my TI calculator. Negative 5 times 4 EE negative 9, close parentheses, equals 3. So the frequency is 3.25 times 10 to the 1, 2, 3, 4, 5th. That's pretty fast. Try this one. So it's 1 over 2 pi square root 7 e negative 5 times 3 e negative 9. So 1 divided by parentheses 2 pi second function square root 7 e negative 5 times 3 e negative 9 close parentheses equals 3.47 times 10 to the 5th. If you have any questions, we do have another section. Sorry about that. I forgot that we went on. How do you use exponential notation for the nth roots? Well, basically what you do is the square root can be interpreted as 1 over n. So for this first one, this is the same as the fifth root of 32, which would be 2. This is the same as the square root of 64, which is 8. This is the same as the fourth root of 81 with the negative sign in front of it, which is 3. This is the fourth root of negative 81. Since this is the negative sign is inside, we would say that's null set. The cube root of 64 with a negative sign is negative 4. And the last one, it's 1 over, I'm sorry, the cube root of 1 over 27, which is 1/3. Try these. First one is the square root of 81, which is 9. The second one is the cube root of 125, which is 5. The fourth root, with the negative sign out front of 625, is negative 5. If you put it on the inside with an even root like that, you get no answer. The cube root of 125 with a negative sign is negative 5, and the fourth root of 116 is 1/2. So for this one, it's the cube root of 125, which is 5. If you have a to the m over n, basically what we're saying is we can take that number to that power. So in other words, in this case, we can take the square root here to the third, which is 125. We can take the cube root here, which is 3, squared is 9. The square root of 16 is 4, cubed is 64 with a negative sign out front. The cube root you can do, and you get negative 4, but then when you take the square root of that, you get a null set. The square root you can't do, so you get a null set right away. Interestingly, it doesn't matter either way. You get a null set whenever you have an even in either the numerator or the denominator. So this is the fifth root of 32, which is 2, squared is 4. The cube root of 8 is 2 to the fifth is 32. This would be the square root of 100 is 10, cubed is 1,000 with a negative sign on it. Remember, it's see that there's an even and an odd, you're going to get the null set. Oops. In both of these cases, because you've got even and an odd. If you have a negative sign in front, that means you take the reciprocal of it. A negative exponent does not necessarily lead to a negative result. Negative exponents lead to reciprocals, which may be positive. So this is the fourth root of 81 is 3 cubed in the denominator. So it's 1 over 27. The square root of 36 is 6 cubed in the denominator. Notice this negative sign tells us to put it in the denominator, which is 1 over 216. The square root of this is 8 over 5. Cube each of them, but then switch them around so the 8 is on the bottom, the 5 is on the top. 5 cubed is 125. 8 cubed is 512. I'm not sure if that's right or not. It's close. Okay, you do these. So the fifth root of 243 is 3. Cubed on the bottom is 1 over 27. B, square root of 4 is 2 to the fifth is 32. On the bottom, 1 over 32. And for the last one, the cube root of each of these is 6 over 5 squared, and then switch them around. So 5 squared over 6 squared is 25 over 36. 100 to the negative 7 halves. Square root of 100 is 10. To the 7th is 1 over 10 million. Okay, so it doesn't matter which way we do it when we see m to the nth. If all the roots are real, then m to the nth is, you notice the m goes on the inside of the radical and the n becomes the index. Or we could take the nth root and then raise it to the mth power. It doesn't matter which way you do it. Whichever way makes it easier to do. Oops. Write each exponent as a radical. This would be the square root of 19. This would be the fourth root of 11 cubed. This would be 14 times the cube root of x squared. This is 5 times the fifth root of x cubed minus the fifth root of 2x cubed. And this would be 1 over the seventh root of x to the fifth. And this is the cube root of x squared plus y squared. This one would be, now we're going the other direction, so this would be 37 to the 1/2. This is 9 to the 8/4, which is 9 to the second, interestingly enough. Why they put that one in there? That's kind of a weird place for which would be 81. Usually they don't simplify out. This is z to the 8/8, which is z to the first. Okay, write each exponential as a radical. Assume all the variables represent positive real numbers. So we've got the square root of 21 is the first one. The fourth root of 17 to the fifth is the second one. 4, fifth root cubed. 4t root squared. 1 over the fifth root of w squared. And the last one over the fourth root of b squared. In this case, we have to go the other direction again. So this would be 15 to the 1/3. The next one would be 4 to the 2/4, which is 4 to the 1/2, which is actually the square root of 4. So that is the same as 2. And then the last one would be x to the 4/4, which is just. Okay, so this one is the fourth root of parentheses. Make sure you get the parentheses. No, you don't need parentheses. Sorry. 6py squared. I think the 2 is on the outside. It's not. So it's the fourth root of 6py squared. There we go. How do you use these rules with rational exponents? Well, we know you can multiply them, so on, add them, subtract them, switch them around, and those kinds of things. So let's see how you would simplify these. This is the same as adding them, so it's 1/2 plus 1/3, which is 3 to 6 plus 2 more 6 is 3 to the 5/6. This is 7 to the 2/3 minus 4/3 is 7 to the negative 2/3. And we want it to be only positive exponents, so we write this as 1 over 7 to the 2/3. This would be, remember this is going to go in each one of these. So A, 1/3 of 6 is 2. 2/3 of 6 is 4 over b to the 6th. Now we can subtract, so we get a squared over b squared. Okay, this one tells us to switch them, so I'm going to do that right away. A to the negative 2, b to the 1/5 over a cubed, b to the negative 4th to the positive 1/2. Now I'm going to put this into each one of these spots. Half of negative 2 is negative 1. 1/5 of 1/2 is 1/10 over a to the 3/2, b to the negative 2. So now we're going to subtract. This is negative 1 minus 3/2. This is 2/2. 2/2 minus 3 more halves is a to the negative 5/2. b is to the 1/10 minus negative 2 is the same as b to the 2 and let's make this 20/10. So 1/10 plus 20/10 is 1/10. b positive 21/10. We want them to have only positive exponents, so we're to the bottom. So it'll be a to the positive in the denominator. Okay, the first one would be 5 to the 1 2/3. We meet at 12, that's 3/12 and 8/12 is 11/12. 5 to 11/12. B is 9 to the 3/5 minus 7/5 is negative 4/5, so it's 1 over 9 to the 4/5. C, we have to put this into each one of the places, so we get R t squared over t to the 8th. Subtract this is negative t to the negative 6, which means we can put it on the bottom, so we'll have r to the 16/3 over t to the 6th. This one, we have to multiply it by each one of those, so it's y to the 2/3 plus 1/3 plus y to the 2/3 plus 5/3. 2/3 and 1/3 is y to the 1st. 2/3 and 5/3 is y to the 7/3. Okay, so we're multiplying means we add the exponents. 1/9 plus 8/9 is 9/9, which is x. Write all the radicals as exponents and then simplify for rational exponents. Leave the answer in exponential form. So I think the easiest way for me is to switch them to fractions first. 3/4 plus 1/5. They meet at 20ths. That's 15/20ths plus 4/20ths is 19/20ths. So it'd be the 20th root of x to the 19th. This is x to the 5/2 over x to the 1/3. So it's x to the 5/2 minus 1/3. Those are sixths. So that's 15/6 minus 2/6 is x to the 13/6, which is the 6th root of x to the 13th. This is the cube root of x to the 1/6, which is x to the 1/6 to the 1/3. So multiply those two, you get x to the 1/18, which is the root x. This first one would be y to the 3/5 plus 1/3. 3/5 plus 1/3 meets at 15ths. 9/15ths plus 5/15ths is 14/15ths. So it's the 15th root of y to the 14th. B is y to the 4th over y to the 1. So y 4th minus 1. You get 20. This is 15 20ths. 4 20ths is 11 20ths. So it's the 20th root of y to the 11th. This last one is the square root of y to the 1/3. Y to the 1/3 to the half. 1/3 times half. 6. You do this one, it's x to the 5/6 plus 4/5. They meet at 30ths. It's 25/30ths plus 24/30ths is 49/30ths. So it'll be the 30th root of x to the, oh, I'm sorry. Yeah, 30th root of x to the 49th.